Hey guys, in this video we are going to learn how you could build your very own Haar Cascade to detect custom objects. In our previous video we had seen an example of detecting cars which was done using a pre-trained Haar Cascade, and even OpenCV provides few pre-trained Haar Cascades that are seen here, like eye, frontal face, full body, license plate. But if you want to detect something that is not provided, you would have to create your very own Haar Cascade, get the XML file and then use it for detection. So we'll see how that's done in Windows. So there are three methods by which you could do that. The first is a well documented file provided by Auckland University, which basically uses just the command prompt and commands, and it's a very tedious process to this methodology is a very tedious process. So I tried it out with around 200 positive images and 500 negative images. It takes around 6 hours to train, and that at the end the results were also not that great. So this is a bit outdated right now and is not recommended. The second method was by one of my favorite YouTubers, Sendex. It's an excellent method, but the problem is that it's not actually using Windows. So you need a basic tier of DigitalOcean or AWS to do this, and you have to pay a very basic amount. It's a great method, but it's not using Windows. The newest method was this. A GUI was built by a developer named Amin Emadi, and it's also open sourced here. You could go through his blog, and the download link is at the bottom. So download this GUI and install it with default instruction. So we would be using this method to train our Haar Cascade, and our goal for this video would be to detect faces. So detect faces, you need data. So the data that I would be using is the CK data set, which is again open source. You just need to provide few details here and you could download the data set. So once you download the data set, you need to do the following. So collect the data set, both positive and negative images. Positive images are those that contain the object that we want to detect. So if you are training it for faces, positive images have to have faces. Negative images are those that do not contain the object to be detected. That is, there should not be any faces in the negative image. So I'll show you my positive and negative image. So these are the positive images. They are 50 in number. So these are only containing faces. That is what we want to detect. And these are my negative images. These are those images that do not contain faces. So strictly there should not be any face in these videos. So once you do that, okay, so what if you do not have a data set? Right now I had a data set for faces. What if you're detecting something like probably tender coconuts? So if you're detecting something like tender coconuts and there is no data set for this, one thing you could do is go to images and see the search results. So instead of clicking save on each of these images, there is a dope Chrome extension called Fatcon, which you could use, and just I would demonstrate it here. Click on this tab and this would download in bulk every image that is present in the search result. So you could get around 200 images of this. And even then there is this excellent UCI machine learning repository which contains lot of data. You might sometimes find what you need here. So you could use even this. Okay, so all that done, once you collected data, you need to create a positive image folder that contain the object to be detected, negative image folder that do not contain the object to be detected. Once you've done that, open the GUI tool. So the first thing you need to do is provide the path where the data set is located. So this is the parent directory of the data set, the custom Haar Cascade, which contains N and P. So you have to name it N and P. That is how the GUI was built. So once you provide the path, the other parameter that you need to set is the number of stages. That is the number of iterations that takes place on the training. If you set around like 30 stages, be prepared because it will take a lot of time. Right now I'm setting just 15 stages. So you could try it out and see which gives you the best accuracy, and keep rest of the values default here. So I've changed only the number of stages, and in Cascade you have to change the sample width and height depending on the images that you're using. So right now my positive images are a few bigger in size when compared to the default value. The default value is 24, but I'm using 32. Rest of the things can be the same. Don't go to change it unless you know what you're dealing with. So once you create all the path, you set the number of stages, you give the width and height, you could start the training. So this is how the training happens. It gives you a log of everything that is happening here. So while the training is happening, don't perform any high GPU consuming tasks like playing a HD video or something. both are going to probably crash, both the training tool and your whatever you're playing the video on. So while this is going on, let me demonstrate how Haar cascades actually work. So this is a famous image of Lena. So what happens here is a 24 cross 24 target window is used in Haar cascade. So within each target window, you would have features. So the black and white thing that you see is called features. There would be edge features, line features, rectangular features. Each feature is moved over the image and a value is computed, and this value is computed using the concept of integral images, and then you would select the best values using something called as Adabush classifier, and then you would cascade them. So basically Haar cascades are a 4-step process. First feature is Haar features. So Haar features are these white black boxes that you see. Next feature is integral images. Integral images are mathematical tricks to fasten the process of computing. And the third is Adabush classifier. So if you're familiar with something like if you're familiar with something like extracting the best features and rejecting all the unnecessary features, that is what Adabush does. It selects only the relevant features and discards everything that is not important. And cascading just cascades everything. So in the first cascade you would have some features, in the next cascade you would have some features. So this is just a basic overview. There is something more deep in it, but I've just provided a basic overview, and these are the stages. So here you can see there are 22 stages set, and the features are iterating, and the value keeps computing. So let's see what's happening with the training. So it's still training. So these are the steps that we had followed: collect positive images, negative images, create a folder P with positive images, create a folder N with negative images, then use the Haar trainer GUI to train, specify the path, then set the stages, set the width, set the height. Okay, perfect time, and it's finally ended. So the training is completed. So once the training is completed, in the same parent folder, these are the folders that would be generated. So you could ignore these. They are basically vector files of pre-computation, and then go to the classifier folder. So this is your final outcome, the final thing that you got after training. So just I'll copy this, I'll paste it here right now. Okay, let me just paste it. Okay, it got pasted here. So this is the XML file that got generated after training. It didn't take a lot of time. This is the best thing about the GUI. The first method by Auckland University, it takes a lot of time and there is no guarantee for it to work. And once the cascade file is generated, I wrote a simple code here. So this code basically reads the cascade file that is generated, and then I'm using a test image here. So I'll show you my test image. So this is my test image to see whether it detects this face or not. So where did the code go? Okay, so this is the test image, and then as always BGR to gray, because we would always use grayscale, and then the detect multi-scale. If you want more details, you could see my previous video where I explained this code. So the first argument it needs is the gray, and then the scaling factor and the min neighbors. Here the min neighbors is high, and because there would be only one object or a one face in an image here, you could tune this value, and then you draw the rectangle. For in-depth details, see the previous video, and then you would show it. So let's run it and hope that it detects. Okay, check module, there's no errors, and let me run it. Okay, there you go. So as you can see, it's properly detected the face. So if you're doing it for any custom objects, you could train it for more number of images to get better accuracy. Right now there are no false positive, all false negative. And what is recommended is, if you have 50 images in positive, you need to have double the amount of images in negative. So I have 108 images in negative and 50 images in positive. One more best thing, that if you have images in grayscale, it would be the best. It could even fasten the computation and also remove lot of noise like luminescence or brightness that is present in the color images. So that's pretty much it. To summarize what we had done. What we had done was we had used the GUI tool because it was one of the best methods which you could do it on Windows. We provide the path here, and the path should contain two folders: positive images, which contain the object to be detected; negative images, which strictly do not contain the object to be detected. There should not be any faces in this, and be very careful when selecting your data. If you are training for about like 500 images and you don't pre-process your data well, it's going to be a waste of lot of time. So once we selected the folder, then we gave the number of stages. You could set this to about 52 if you have a lot of time and computation power. Right now I have a 8 GB system, and it took around just like 2 minutes to train basically. Then you set the sample width, sample height, set the sample width and the sample height. You could start your training. So based on the number of stages, it would train, and once the training is complete, it would generate an output file, which is an XML file. This is the main file that is generated. You could ignore all this. This is basically the log. And once you get this XML file, you could use it to detect your objects, as we did it here. We pasted it here, and then we trained it, and then we tested it on one of our images, and that's how it worked. So this is basically how you create your custom Haar Cascade on Windows. So if you have any other feedback or suggestion or any video ideas that you want me to do mention it in the comments, and I would be happy to help. Thank you for watching. Do like, share and subscribe.